All right, guys, here we are, day number 8, inverse, cosine, and secant. All right, so what we are going to be looking at is we're going to, just like we did with inverse sine, we're going to find our restricted domain for our inverse cosine, then we're going to practice unit circle, and then we're going to do some non-unit circle. All right, here we go. If I can find the mouse. There it goes. Okay. So, we talked about inverses last time. We talked about what the difference between inverses versus normal trig functions are. All of that is the same. So the only thing we're really looking at is cosine, how it's different than, oh, I forgot to change the, hold on. This should say cosine. Oh, ergo. I don't know why I forgot to change that. I changed everything else to say cosine. Doesn't matter. Okay, so we're just going to be looking at the restrictions basically for cosine versus sine, right? And this goes for secant as well. So anytime we're talking about inverses with cosine, secant is the same thing because it's the reciprocal, so they go together. All right, so we're going to start by graphing our normal cosine graph, and then we're going to look at how we're going to pick that restricted domain. So here we have 0, this is 1, 0, -1, 0, and 1. All right, and then we're going to sketch our cosine. 1, 2, 3, 4, 5. Okay, so we have 90, 180, 270, and 360. -90, -180. All right, and then we have +1 and we have -1. All right, so here is our wonderful cosine graph. So sketching cosine, we have up at 1. I don't like cosine as much. I don't know, it just doesn't look as pretty to me. I know when you keep doing it forever and always, they look exactly the same, but like one cycle of cosine, just, I don't know, something about it, I just don't like it. Okay, anyways, there's our cosine graph. Okay, so we have the same dilemma with sine. So again, cosine is not a one-to-one function, meaning its inverse is not a function. Sorry, my dog is barking at probably the mailman. So the inverse of cosine is not a function. So we need to figure out an interval where we can restrict our domain so that we can include all the y values, so from -1 to +1, but we don't want to repeat any of the x's. All right, so with this one, it is kind of more obvious than it was with sine. So you do just want to start at 0, and because we're at +1 at 0, right? So we just want to go from 1 until it hits -1. Which is going to be right here. All right, and if you look at just this section of the graph, we cover all of the y values. Like I said, we go from -1 to +1, and we don't repeat any of our x's. So this section of the graph passes both a vertical and a horizontal line test. So this is the section that we're going to use for our inverse cosine. All right, so restricted domain is going to be from 0 to 180 degrees. All right, which, if we're thinking about it, this is quadrants 1 and 2. Right, so if we're thinking about our unit circle, right, this is quadrants 1 and 2. We're going to cover all of our values from there. All right, so moving on to inverse cosine. All right, so to graph our inverse cosine, all right, remember we are swapping our x and our y axes. I'm just going to do it above because that's nicer. I don't think I need to go all the way up there. But we have -1 and we have +1. All right, this is 90. This is 180, 270, 360. And we look like this, right? So this is bam, 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 bam. Great, so there's our graph, and remember we are mostly looking at just this section of the graph, right? That part right there where we're spanning from 0 to 180 and we cover -1 to +1. All right, so our domain for our inverse cosine, which again, we have cosine to the power of -1 as one of our ways to write inverse. We also have the arc cosine option. Both of those represent inverse, just two different ways of writing it. There is absolutely no difference. All right, so domain, we are going from -1 to +1, and our range is from 0 to 180 degrees. All right, so moving on to some practice problems. All right, now I have, let's see, did I save it? I did not. That was the last thing I copied. So, oh well, that's fine. I have it, actually. I saved it right here. Oh. You guys can't see what I'm doing, so it's, no! Come here, my pretty. There we go. All right, just so we have it there as like a nice visual to look at. Our little unit circle values. Okay, so view, let's zoom in a little bit. There we go. Okay, so now we're gonna do the same thing. So the only difference is that instead of pulling values like we were with sine from quadrants 1 and like kind of like quadrant -1. I know it's quadrant 4 on the XY axis, but we're not really using quadrant 4 values, right? We're just using negative first quadrant values. Okay, so like I said, with cosine, we're pulling them from quadrants 1 and 2. So it's a little bit more straightforward, more closely related to your unit circle. All right. So the first one says sine of arc cosine of 1. So this is a two-part problem. We did a little bit of two-part problems with our inverse sine video. All right, so hopefully this isn't too crazy. You always start from the inside. So we want to solve the inside piece first. So we want to say, okay, what is the arc cosine of 1? Meaning, what angle has a cosine value of 1? So now we're looking in that cosine column. All right, and we want to find 1. Well, that's right here at the top. All right, so we have cosine value of 1, and if we look over to what angle that matches up with, that is 0 degrees. All right, so we're going to plug in 0 for arc cosine of 1. So the angle that has a cosine value of 1 is 0 degrees. You can even put a little degree symbol there if that helps you. So now we need to do the other part of the problem. So we're bringing down the sine. And this is just asking a normal straightforward trig question. What is the sine of 0 degrees? So you can go to the 0 degree row, right? All right. So now we're at the 0 degree row and we want to know what is the sine of that angle, which is 0. So ultimately the answer is 0. That is our final answer. All right, moving on to our next one. So we have inverse secant is negative square root of 2. Now we're not going to find any negative values in this chart because this is only quadrant 1 values. So we'll deal with the negative after, like in a second. So we're going to look at the secant row. All right, and we're going to say, okay, when is it the square root of 2? Right here. Well, we follow our chart backwards. And we see that that matches up with the angle 45 degrees. So I'm going to plug in, oops, that is the highlighter still. I'm going to plug in 45 degrees because that is inverse secant of negative, oh, no, it's not. Ah, I lied. All right, so 45 degrees matches up, but we have a negative square root of 2. Forgot all about the negative. All right, so since it's negative, that doesn't happen in the first quadrant. So that means we have to go to our second quadrant to find the negative value because cosine is negative in quadrant 2. All right, so we have to think, okay, we're dealing with 45 degrees. So what is the 45 degree angle in quadrant 2? Well, that is 135 degrees. So the answer for this is actually 135 degrees. Okay, so remember, since it's negative, we have to take our second quadrant value. All right, last piece. Bring down that cosecant. So I want to know, okay, what is the cosecant value of 135 degrees? Right, well, 135 degrees isn't on our thingy, but we know that this is 45. So we know that this is the 45-degree angles. All right, we just have to keep in mind, what is cosecant going to be in the second quadrant? Is it going to be positive or negative? All right, and we'll deal with that when we get to that part. So for the 45-degree angles, our cosecant value is the square root of 2. All right, so we know that this is going to equal square root of 2. Now, is it going to be positive square root of 2 or negative square root of 2? In the second quadrant, our cosecant value, which is our reciprocal of sine, is positive. So this is positive square root of 2. That is our final answer. All right, moving down to the non-unit circle inverses. So I only did one of these on our last video. I'm gonna do both of them this time because we're going a little bit faster. We didn't have to talk about a lot of the notes stuff because we already had done that the previous day. So I'll do both of these. Okay, so for non-unit circle, all right, it's giving us the ratio, right? Remember, with inverses, it's always giving us that coordinate or that side ratio or something to deal with the sides, like the coordinate, whatever you want to think of it as, of the triangle. All right, so for this first one, it's telling us that we have a triangle that has a cosine value of square root of 5 over 7. All right. Well, we know that cosine is adjacent over hypotenuse. So we have two sides of a triangle. The adjacent side is the square root of 5 and the hypotenuse is 7. So I'm going to go ahead and sketch this out. This is also positive, so I'm going to draw a first quadrant triangle. All right, and adjacent, so this is my angle. Adjacent is root 5, hypotenuse is 7. All right, to find the other side of my triangle, I need to do the Pythagorean theorem. So I have 7 squared minus root 5 squared equals my y value, I guess. It doesn't matter, you can call it x, it doesn't really matter. We're just kind of sketch out a triangle, right, squared. All right, I'm gonna go to my trusty calculator. 7 squared minus root 5 squared, that's 44. All right, so this is 44. All right, take a square root of both sides. And yes, I do want you to simplify the square root of 44. So there is a perfect square that is in 44. It's 4. So this simplifies to 2 square root of 11. All right, so yes, you do have to do that. So please don't ask me again. Yes, you always have to simplify square roots. Okay, so that means my missing side is 2 root 11. Okay, so now I can answer the final part of the question, which is what is the sine of this triangle? All right, so sine is opposite over hypotenuse, so it's going to be 2 square root of 11 over 7. That is my final answer. Okay, moving on to the second one. So we have a secant problem here. So again, we're going to use this to set up our triangle. Now I'm going to help you with simplification with this one. So I put this one on here for a reason. I gave this on the test last year, and a lot of people got this one wrong because they didn't simplify first. They didn't kind of like use their head, so they ended up with numbers that were really large, and it really made them mess up. So I'm going to show you the easiest way to do this problem. All right, we have 3 square root of 7 over 7. I want you to think backwards. All right, you have root 7 over 7. That looks like it was like a rationalized denominator. Like that's a pattern that you guys have seen, right? If you have a square root on the bottom, to get rid of it, you multiply top and bottom by that square root, and then you just get the whole number on the bottom and the square root goes to the top. Well, that's what has looked like it has happened here. So if you want to make your life easier, don't use these values as your sides. Treat it as if it was not rationalized. So treat it as if it was 3 over square root of 7, which is what it is. All right, this just, like I said, got rationalized, so it doesn't have the square root on the bottom. I know this might sound like you're changing numbers, you're changing something, but you're not. You're just unsimplifying it. And the reason I really recommend doing this is because it does make your numbers smaller than they would be if you dealt with it as like the square root of 7 over 7 kind of thing. The numbers are bigger, and then you have to simplify, and then it gets weird, and then people don't do it right. Okay, so it's not like it's a hard problem. It's just, like I said, you guys are bad at simplifying. Like I'm not gonna sugarcoat it. You guys don't do it well, all right? And I find out every year. So just wanted to show you the shortcut for this. So you can do it like this. Treat this as, so secant, this would be my hypotenuse, and this would be my adjacent side. All right, so now I'm gonna draw my triangle. Again, it's positive, so I'm in the first quadrant. So I'm just gonna draw a first quadrant triangle. All right, so hypotenuse is 3, adjacent side is root 7. Cool. Now I'm going to go ahead and do Pythagorean theorem. So 3 squared minus root 7 squared equals y squared. So that's 9 minus 7, which is, what is that, 2? Yeah, 9 minus 7, 2. 2 equals y squared, square root both sides. So we have root 2 equals y. And that can't be simplified anymore. It is what it is. Okay, so now we're going to go ahead and we're going to find the tangent of this triangle. All right, so tangent is opposite over adjacent. So we have square root of 2 over square root of 7. Now we're going to rationalize our denominator, multiply top and bottom by square root of 7, and you get square root of 14 over 7. And that cannot be simplified any further, so that is our final answer. All right, that is it for inverse cosine. All right, so see if you can do your homework for inverse cosine. I know, especially with the unit circle ones, it takes a while to get used to this. Practice, I guess, is really all I can say. It does make it nice if you have your unit circle out in front of you, but it is also important that you are able to do this without looking at a unit circle. You should be able to get kind of used to doing this just from memory. And I know that that's tricky and it sounds really hard, but the more you practice doing it without your unit circle, you will eventually get faster at it, and ultimately it will make you better at this stuff. So that is it for today, and I will see you guys in our next video.